Everyone, welcome to this explainer. If you've been scrolling through the news lately, you'd probably think the EV revolution is just straight up hitting the brakes. But honestly, the truth is so much more interesting. The market isn't dying, it's just growing up. We're shifting away from a chaotic period defined by policy-driven hype into a much more stable, mature era built on real-world fundamentals. Today, we're going to explore the powerful undercurrents that are actively reshaping how we drive, how we get our packages delivered, and how our cities actually operate.
All right, let's look at our roadmap for this explainer. We're going to cover 1. The real EV sales story. 2. Smarter, faster EV charging. 3. Powering the commercial fleet. 4. The robo-taxi charging challenge. And finally, 5. The solid-state battery era. Let's jump right in.
Section 1. The real EV sales story. A tale of two markets.
To get what's actually happening with sales, we have to look way past that surface-level narrative about slowing new EV adoption. Sure, new EV sales in the US dropped by about 27% year-over-year in the first quarter of 2026, with market share stabilizing around 6%. But, that was entirely expected. Federal incentives expired, so the market had to do a hard reset. But here's the wild part. While new sales were recalibrating, the used EV market absolutely boomed. We're talking a 12% jump year-over-year, hitting 93,500 units sold nationally. And these used EVs, they're flying off dealer lots in just 42 days on average. That is almost identical to gas cars. So what does that tell us? It tells us we're looking at genuine, massive consumer demand, not just a bunch of inventory collecting dust.
So the real takeaway here is that consumer interest hasn't died out at all. It's just shifted gears. And it's all driven by an incredibly narrow price gap. Get this, the difference between a used EV and a comparable gas car is now just $1,300. Just a couple of years ago, back in early 2023, that gap was over $10,000. Now with the average used EV sitting around $34,800 and nearly 44% of those transactions coming in under the $25,000 mark, electric driving is suddenly an option for a massive new wave of households. We're talking about the pure fundamentals of affordability taking the wheel. This means the EV market is finally unlocking for the everyday driver, not just early adopters with tons of cash to burn.
Moving on to Section 2. Smarter, faster EV charging infrastructure matures. As everyday adoption stabilizes, it heavily relies on our second big undercurrent, a much more reliable charging infrastructure. Look, we all know the frustrating days of pulling up to a broken charger. Well, those days are rapidly ending. In the first quarter of 2026, most states are seeing uptime reliability hitting 90 to 95%. That is a massive jump from the 85 to 92% range we were stuck in just a year ago. Now, I know uptime percentages might not sound super flashy, but it is absolutely crucial for consumer confidence. It means newer equipment, vital upgrades, and operators finally getting the hang of managing their network smoothly.
And the whole charging landscape is totally diversifying right before our eyes. Tesla is obviously still a heavyweight, but their share of new fast charging ports dropped to 26% in early 2026, and that contraction is making plenty of room for smaller and mid-sized networks to absolutely surge, capturing over 30% of new deployments. We're seeing newer players like Iona and Red E gaining serious ground. To put that into perspective, 6 of the top 10 charging providers right now weren't even in the top 10 a year ago. It's like a whole new ballgame. The network is scaling up in a really controlled, distributed, and fiercely competitive way.
Plus, with operators packing way more chargers into each site and average prices holding rock steady at about 53 cents per kilowatt hour, high-power charging is literally no longer a premium perk. It is the baseline. A staggering 67% of new ports deployed are now rated at 250 kilowatts or higher. Because those ultra-fast speeds are just becoming the industry standard across the board, companies can't just coast on speed anymore. They've got to compete on reliability, smart load management, and overall consistency.
All right, Section 3. Powering the commercial fleet, the last mile.
Now, zooming out from our personal cars for a second, we really need to wrap our heads around the massive scale of urban delivery. This accounts for a huge chunk of road freight emissions, especially when we talk about that critical last mile and the final 50 feet. I mean, think about it. The explosion of e-commerce and same-day delivery has just flooded our streets with delivery vans and box trucks, all fighting for the exact same curb space. Right now, a whopping half of all road-based freight emissions actually happen during this very final stretch of delivery. It's this incredibly complex ecosystem of shippers, carriers, and local receivers, and cities are just desperately trying to manage and decarbonize the whole thing.
To untangle this mess, the Urban Freight Lab uses a concept they call the three-legged stool as the ultimate foundation for zero-emission delivery. And it highlights a really important point. It's not just about swapping a gas van for an electric one. You need a completely holistic approach. Leg 1 is, of course, the electrification of commercial fleets, but leg 2 is mode shift, literally changing how we deliver, moving away from traditional trucks and towards smaller, nimbler things like cargo e-bikes, personal delivery robots, or even drones. And the third leg? Real estate. Cities and companies have to totally reimagine space management. That means creating delivery micro-hubs or taking vacant retail spaces and retrofitting them to support these brand new logistics networks.
But, as you might guess, electrifying a massive fleet brings some pretty severe infrastructure headaches. The grid just gets bottlenecked. So to solve these immediate grid capacity issues, fleets are getting creative. They're increasingly utilizing off-grid mobile battery chargers to power up, rather than waiting around for permanent infrastructure to be built. Companies like SparkCharge are stepping in with charging as a service, literally delivering fast, grid-free energy straight to the delivery yards. It's a real game changer because it completely bypasses the downtime, the agonizingly slow construction permits, and the massive upfront capital costs you normally need to upgrade a depot's electrical capacity.
Next up, Section 4, the Robotaxi Charging Challenge, Autonomous Fleets.
Now this brings up such a fascinating logistical hurdle. How on earth do you charge a commercial fleet of robotaxis when there is literally no human driver around to plug them in? Unlike our private cars, robotaxis are out there hustling nearly 24/7, and they return to really high-density depots. Because they drive themselves, they need highly specialized infrastructure. Enter automated charging systems, developed by companies like Joule Labs. These wild setups use robotic arms, sensor-based alignment, and direct vehicle communication to connect the chargers seamlessly, with zero human intervention. It's basically this beautifully orchestrated robotic dance, all managed by software, ensuring the exact right autonomous vehicle rolls up to the right robotic charger at exactly the right time.
And make no mistake, this is not just some quirky niche experiment. Industry giants like Uber are actively rolling out 1,000 high-powered DC fast-charging points just to support this rapidly expanding robotaxi ecosystem. Uber has committed over $100 million, partnering up with companies like EVgo and Electra. They're doing this to ensure their expanding autonomous fleets, which are operating everywhere from Los Angeles all the way to London, have the rapid turnaround they desperately need to stay profitable and, more importantly, stay out on the road.
Which brings us to Section 5, the solid-state battery era, the deepest undercurrent.
All of this infrastructure build-out is setting the stage for a technological leap that honestly changes everything. When we compare traditional lithium-ion batteries side by side with 2026 solid-state technology, we're looking at a massive generational leap in both safety and extreme weather performance. See, traditional lithium-ion batteries rely on a liquid electrolyte to move ions around, and that liquid can actually ignite if the battery gets damaged. Solid-state technology just completely replaces that with a non-flammable solid material, stuff like polymers, oxides, or sulfides. Just look at the numbers. Thermal runaway, which is when a battery gets dangerously hot, gets pushed from a risky 90 degrees Celsius all the way up to 247 degrees. Plus, the energy density nearly doubles. And my favorite part? Even in totally freezing -30-degree weather, these new batteries still retain over 70% of their capacity.
Because of these massive breakthroughs, major manufacturers are currently in an absolute dead sprint to commercialize this tech. Why? Because it effectively neutralizes every single lingering consumer anxiety about range and charging times. By using these solid electrolytes, we basically suppress the growth of dendrites. Those are the pesky little metallic whiskers inside a battery that cause short circuits. By stopping them, we can safely use lithium metal anodes. And the result of all that chemistry? A staggering potential range of over 1,200 kilometers, the ability to juice up to 80% in just 10 to 15 minutes, and a lifespan of over 1,000 charge cycles. We're actually seeing the phase-in of semi-solid batteries right now in the market, which is perfectly paving the way for true 100% solid-state mass production in the very near future.
So, what does this all mean? Well, the timeline for EV hypergrowth may have shifted a bit, but the direction? The direction definitely hasn't changed. That slowdown in new car sales you heard about was really just a surface ripple, because underneath it all, we have a surging used EV market, highly reliable high-speed charging networks, a total revolution in the commercial delivery space, autonomous robotaxi infrastructure being built out as we speak, and breakthrough solid-state battery chemistry hitting the streets. The true EV revolution isn't just about the car parked in your driveway anymore. It's about how our entire world is being rewired from the ground up. The real question is, as the market shifts from policy-driven hype to these rock-solid fundamentals, are you ready for the next chapter? Thanks so much for joining me on this explainer, and keep learning.